Hi everyone. Nice to see you all today. Welcome back to week 7. I hope you all enjoyed your flex week off. Did anyone do anything exciting? Anyone got any crazy holidays, or did you just spend time working on university assignments? Because I assume many of you, or how many people wanted to spend time taking a break and then you just spent it working on assignments? It's been a while. A week off, assignments, great. Okay, cool. Yeah, I mean, flex week, it's a weird week. It's a very strange week, because it isn't really a week off. But it kind of is, but it's kind of not. But good to hear, at least if you didn't take a break, that you got to spend some time doing uni work that you don't have to do this week, I guess is one positive of it. Today we have a set of things to go through. But overall not too bad, because we kind of have these 3 lectures on requirements, and then we get a little bit into system modeling, and then the last one we do a little bit of a bonus lecture on Git. So, and this is good because like it's not a lot of programming. So like the information you take in this week, like you're probably all sitting around writing a lot of code, doing a lot of programming. Your brain's probably melting by now. But we're going to talk about some waffly stuff today. The mic is not different, unless there's something wrong with it. If there's an issue with the mic, let me know. So let's get into it. So the first 3 lectures, which are probably, I would guess, what we're going to go through today. We'll see how we go for timing. That's not good. It's a little tinny. Okay. I'll check that out soon. Let me just triple check the sound. One sec. Let's get stuck into it. So 7.1 today is an overview of Sdlc requirements. So Sdlc requirements. What exactly is Sdlc requirements? So you know from this diagram that we've been talking about since week 1 that there are some critical steps to the software development lifecycle, starting from requirements analysis and finishing with maintenance, right? So we move around that way, whichever way my camera works. And we've kind of talked about testing a bit. We're going to talk about deployment next week. We've talked a little bit about design, and we've talked a little bit about development too. We were going to talk about this earlier, like back in week 3. However, instead, we thought, let's push it back so that we can actually spend some time on other things. So we're finally coming back to it now, and we're talking about the yellow part, right? The requirements analysis part. And to understand requirements analysis, you first, I guess, have to understand why we care about it. And the reason is because out of all of these steps, the yellow one is arguably the single most important one. It's the one that if you get it wrong, everything else kind of fails after it. And that's because you need to understand why you're doing what you're doing and what you're actually trying to achieve, right? Because the second you start designing something is the moment you're in solution mode, right? Like requirements analysis, the yellow box, is problem mode. You're trying to understand what problem you're trying to solve. And then everything else after that, design. You're now designing a solution, right? Development, you're coding the solution based on the design. Testing, you're testing if the solution works. You're kind of testing if the solution solves the problem. So, you know, if you don't get the yellow part right, then you're going to be testing the wrong thing. So everything kind of hinges around this idea of understanding the problem, and that's what requirements analysis is. So a lot of it comes back to this question of why. Like, why are we doing something? And in the world of requirements, even if you don't think you understand it, you've seen it kind of happen before, right? Like you've seen it happen, you know, whenever they build a building, right? Like who's seen a building go up? Who's seen a skyscraper go up? The Barangaroo building in Sydney. You know what it's like, right? There's all this time that passes where everyone's just sitting around seemingly doing nothing, and then suddenly out of nowhere the building rockets up. And that's because software, like other forms of engineering, building it's actually the easy part. Building it's the part that will be least useful a skill to most people, in terms of like, if you truly excel in your career and your industry in this space, your ability to develop code, the green one, will be one of the least valuable parts of your tool set, right? The stuff that will actually help you make money or actually help you move up to better places within the industry will be a lot of yellow, as well as some blue and some purple, right? In terms of like being able to design and test codes, an underrated skill, but trying to understand the problem you're solving, scope it out correctly so that you're aware of what you're going to do, that is by far the most critical skill. How that actually plays out is that to develop a set of requirements, to understand what problem you're solving, we usually will follow a process called requirements engineering. In reality, you don't always follow this strictly, you don't always follow it to the dot, but in general you can say that it's made up of 4 key parts, right? Elicitation, analysis, specification, and validation. And we're going to step through all of these, but like the words actually are quite self-explanatory in a sense, right? Elicitation is saying, I need to extract information from you, right? Because when you're trying to solve a problem, you need to learn from what's around you. No one really sits down and just says, oh, I know exactly what problem we're trying to solve. You have to converse, engage, discuss, learn from other people. After you've kind of extracted things from people, you need to analyze these things, like collect these thoughts. You need to specify them in terms of turn them into something more readable now. And then validation is the last step, which is kind of tied into testing, which is actually making sure that you have the right requirements. You know, it's kind of before testing, I guess, but you know, sometimes that's bringing your results right back to the people who you started with and being like, is this a good summary of it? You know, so that's the overview, and now we're going to dig into it a bit more. So the IEEE, which is a international body that essentially helps define a bunch of standards, says that a requirement is a conditional capability needed by a user to solve a problem or achieve an objective, right? So that's a big waffly word, but essentially it's a I mean, I was going to say it's a requirement, which is kind of useless, but it's essentially an instruction, but not in terms of the solution to give, but rather the problem to solve a lot of the time. And other ways to think about it are that it's an agreement of work to be completed by all stakeholders, or that it's a description and constraints of a proposed system. The thing about this whole topic is that the reason I think some students find it difficult is because there's not like a hardline definition to all these things. There's not like a, you know, this is clearly what a requirement is, and anything else is not a requirement. Because if you look at your project and you look at like section 6.2 interface, you could argue that these are requirements, right? Because like requirements, like what was the definition of it? It's like a conditional capability needed by a user to solve a problem or achieve an objective. These are kind of like requirements put on you that say like, this is like how your, you know, how your solution needs to behave. This is what it needs to satisfy, right? Like we can test it against this. Like you can provide us with something and we can actually take this interface as a set of requirements and check if your thing does what it's meant to. So, you know, in a software engineering space, if you're working with other developers, something like this might be closer to what you consider to be a set of requirements, as like an interface. But in a broader world, if you're building, say, a complex system for, you know, a university or for some other company, the requirements are going to be a list of things like, again, probably like up here, up the top of the document. So you notice here, besides the information available in the interface, you've been told that the features of Dreams that UNSW would like to implement are the ability to log in, register, and if not registered, and log out, the ability to reset a password, right? So you could argue that these are requirements. These are essentially things that dictate a capability needed to solve a problem. They're rules. You can think about it 100 different ways. So we'll get to functional and non-functional in a sec. Let me come back to this slide, because I think functional and non-functional is a whole other discussion. I mainly want to go through like these 4 parts here, right? So we've just kind of talked a little bit about requirements overall, and now I want to get into the requirements engineering part, because I think if you can understand the flow of requirements engineering, it'll be a bit more obvious to you as to like what these requirements actually are. So requirements engineering is a process of getting requirements. Okay, so requirements are your Bible that everything you do in a project is based off, but you need to actually generate that Bible, if you will. So we need a durable process to do that. And there's a quote here from an author named Brooks, right? The hardest single part of building a software system is deciding what to build. No part of the work so cripples the resulting system if done wrong. If you remember back in week 3 when I talked about verification and validation, I said that verification is making sure that the system is built right. If you remember that, that's what testing is. You're making sure that, like, you know, you understood what you had to build. Did you build that right? Right. That's what the testing component is. The second thing we said, validation, was making sure that the right system was built. Okay, as in making sure that, like, what we actually built solved the problem. And the whole point that's trying to be made here is if we don't have a durable process for determining requirements, if we don't determine the right requirements before we ever start designing software, then all that's going to happen is that you build the wrong thing. You could build the wrong thing the right way. You know, so if someone says to you, oh, okay, I'm really interested in having making it easier to get up and down campus at UNSW. It's like, you could go and build a monorail, right? You could go and build a ski lift. You could go and build a whole bunch of things that don't actually, like, solve the problem at hand because the requirements you work to were not good enough, right? So this is the basis of good engineering, fundamentally. Miguel says, so validation is effectively testing for the requirements as opposed to testing for the code. Yeah, exactly. Because, like, often, I mean, that's a way to think about it, yes. Because often, like, what you can actually see happen is that, like, you know, a requirement for a piece of software might be that a user can, you know, log in and do X, Y, Z. And if you get that wrong, if you get the description of that wrong, if you capture their needs, if you capture the problem in the wrong way, then when you actually produce a solution, it's not going to satisfy the person originally, right? Like in a real world context, like, and again, this is coming from, like, startup space, for instance. If you're trying to build a product for someone, if you're trying to build an app for someone, you can, like, there's a process you go through where you figure out what problem you're trying to solve, then you design a solution, you code a solution, and then you give it to a user. And if you give it to a user and they don't like it, you can have built the software right and designed it right for the problem you understood, right? Like the kind of rules that dictate the problem at hand. And that's bad requirements. That's bad problem understanding. So, like, the problem is a critical part to it. Yuval says, isn't it the other way around? Like, you can get the requirements wrong a bit and then continue to validate it and think you're doing the right thing. Yes, like, that's true. I mean, again, the problem is that this language can be applied at many different levels. So I would kind of say you're both right, depending on how you think about it. But if we dig into requirements engineering more, I mentioned here that it's a process. It's a process you follow to get requirements. You know, so someone says, hey, students, we need you to build a new communication system for UNSW. And you say, God damn it. Okay, well, what are we going to build? And you think, how do we figure out what we're going to build? Well, we need to, like, establish a set of rules, requirements, principles, constraints at the start here so that we can start designing software. So we know what problem we're trying to solve. So we start this process and we describe it as a set of activities that are focusing on identifying the purpose and goal of a software system, which is basically the problem. Like, what problem are you solving? And it's a very human process. Like, most requirements analysis is a human thing. It's not a technical thing. It's talking to people. It's emailing people. It's reading through documents. It's reading through stories. It's reading customer feedback. It's reading survey results. And this is why people that are good at this stuff get paid well too, because a lot of people don't want to do that, right? Like, you imagine, like, you're a software engineer. You're like, okay, I just want to code all day. And it's like, you know, unless you're extremely talented, there's a lot of those people around in the world. But those who can actually understand humans, particularly at a cultural level, and translate what people want into an understanding of a problem to solve is extremely valuable. And I mean, all of this ties back to a concept too, which is that all of the engineering we do is fundamentally about solving problems for humans, right? Like, most buildings we build, and cars, planes, software, electricity grids, we're trying to solve problems for humans at the end of the day, right? And most of the time, in a lot of ways, it's for consumers. It's for people who are actually going to use these things. So we need to understand what we're doing. Now, the first part of the 4 steps is elicitation. And in some ways, this is like this is the most human part of it. The rest of the stuff you could largely kind of like, this is the part that really requires you to get out of your shell with people, right? And elicitation is discovery. Sometimes we refer to it as discovery. You can think of it like surveys, questionnaires, like learning, market research, interviews, focus groups. It's about the humans, yeah. And it's just trying to figure out people. You know, again, like, so someone says to you, okay, everyone at UNSW, Tay, really wants a new communication system. Okay, why do they want it? What do they use currently? What's wrong with what they use currently? When do they want to use it? How do they want to use it? What kind of messages are they going to send? Do they need to do more than send messages? Why do they need to send messages? Why can't they call people? You know, like there's 100,000 questions you could ask on these things to understand people. So elicitation, right? To elicit is to extract, to bring out from people. So if I'm trying to elicit something from people, then I'm trying to learn. Trying to learn from them fundamentally. So if you think about a step like elicitation as basically like getting a raw dump of information, you know, if you were doing a huge project, you'd be doing everything from surveys to interviews to just market research, right? So like in DESN 2000, which is I think a course that some of you might take next term, I tutored that last year, and like there was a project where you had to basically design a smart Opal system for Sydney, right? Most of you are Sydney based, or you've been to Sydney. Hi to everyone who's locked out because of borders. We missed you. You know, with that stuff, it was like define make a smart system so that it's easier for people to actually use the public transport network. So, you know, students there, they did a whole bunch of things. They went and interviewed people one-on-one. They sent out surveys to all their friends on Facebook. They do market research, which might consist of, going and looking at the transport numbers. You know, what types of transport do people use? How many people have smartphones? All of this data exists. You actually just have to do the research, like you're back in year 10 in high school and you've been given some research task. And it's all about pulling information out of people and out of data and putting it down in front of you in a giant blob. The second part here is actually taking all these things and linking them together, right? Like building a picture, okay? Like you have all this market research, you have all this survey data, information, whatever, and you now have to sit down and start categorizing it, right? And you know what this is like, again, because most of you have been through the education system, and you know that, say you're researching for a science report or something, again, in high school, you go to all these websites and you take down all these quotes and maybe all this information, and it's just a dump. And then you actually need to start categorizing it, figuring out what relates to one another. In the requirements space, we're not just interested in that, we're interested in like, what are further questions I have? What are assumptions that are being made here? Where is there conflicts in information? Where are there risks associated here? So, someone says, oh, well, okay, we've got all these people that use this type of transport. Well, then, sure, but, what happens if there's track work? What happens if there's other kind of maintenance, right? You're trying to understand everything you're working with. A lot of the time, how we represent these, like once we move into this analysis phase after we've elicited information from people, is we either write user stories or we write use cases, or both. And this says discuss next week, but we're actually going to discuss this today. It's because I moved this lecture slide. I'm sorry about that. And these are just ways of representing, like, again, this human description of the problem in a way that's very digestible, because you need to be able to understand who these people are. So you analyze these things and you start to break it up and scope it out. The The gap between step 2 and step 3 is a little bit blurry because analysis and specification are kind of the same, and in fact you could argue that some of these steps are part of specification. But if analysis is organizing your thoughts and decluttering things, specification is where you actually say, all right, I've got everything now, let me now turn this into something formal again. So again, if I use the science report and high school analogy, this is where you've got all the information on the internet and the textbook, you've organized it and categorized it, now you actually need to write like a draft, if you will. It could be in many forms. It could be series of dot points, it could be a giant diagram, it doesn't really matter. These are very broad principles that apply to a range of things, so don't think about it too concretely. It doesn't have to be an essay. And this is just about actually writing it down. So, like a good example here is, after you've done some elicitation with people and you've analyzed stuff, you've written down a requirement here as the system shall keep the door locked at all times unless instructed otherwise by an authorized user. When the lock is disarmed, a countdown should be initiated at the end, of which the lock shall be automatically armed if still disarmed. And this is a little bit of a confusing sentence, but a couple of things you notice about it. It's very precise, it's very specific, it's a little bit more sterile as well in some ways. Because when you ask, when you elicit information from people, when you say, how much mayonnaise do you want on your burger? They'll say stuff like, I don't know, like a reasonable amount. And you think, okay, well that's great, but that isn't, you can't translate that to a requirement when trying to teach someone how to make a robot that puts mayonnaise on a burger, right? You actually need to be more specific. So, that's why they call it specification, right? You're trying to refine the picture, package it back up together. And then step 4 is kind of taking what you've done and going back to stakeholders with it. And, then you've kind of validated that your specification of the problems you've elicited is accurate and valid. Now again, this is a very hard topic to talk about because when I first taught this, I found it very easy because you could talk about requirements in a very rigid way, but over the last years, something I've seen a lot is that this translates into a whole bunch of different areas, and just understanding the principles is so much more important than understanding anything concretely. Because a good example is, again, if you're in a consumer space where you're building solutions or finding solutions for customers, like as in end consumers, retail customers, like say you're building, Netflix or something, it's like your elicitation is often for customers, like real customers. I did an interview with Atlassian 2 years ago where they were like, can we talk to you for an hour and we'll give you $100 voucher or something, right? This is how companies do it. And you go on the call and they ask you lots of questions, because you're a current user. Like, how do you use it? What do you use it for? Do you use other products, other competitors? Do you want to see our new stuff? They show you the new stuff. They're like, how would you use this? What don't you like about it? What do you like? Like, this is all research they're doing. And they're doing it with consumers. And when they learn things from consumers and then they finally specify it, when you validate these end consumer products, you go back to the consumers quite a lot of the time. You actually go back to them and you say, hey, here's our new ideas. This is what we're thinking about. Does this actually satisfy your problems? And that helps you understand if you're understanding the problem correctly. Whereas if you're in a business environment, or sometimes what we refer to as like business-to-business relationships, of which UNSW dreams as a example of, right? You're building a product for a company. You might have a mix of both. You might have a mix of talking to all the stakeholders at UNSW, the people in UNSW IT, the people in the education field, or other whatever the hell exists up the top of the uni, and not necessarily always the people that might be using it. In a case like UNSW Dreams, you'd probably be talking to both crowds, right? You'd be talking to the higher ups because you're essentially building a boutique system for, an organization, and you'd also be talking to end consumers to make sure that you build it right. And then there are other solutions which are just purely business to business, right? Like UNSW probably uses a whole bunch of tools that are just used internally by their staff that you never see. like for any like payment systems and stuff. That all you're really doing with is having business to business conversations. So they're kind of the 4 steps. Sorry, I don't know why I said 5. So what are some challenges that we face when we're trying to do this requirements engineering, which again is the process of determining requirements. And okay, no matter how good you think you are, problems you'll come across. Sometimes you don't know the problems that you have to solve until you've designed or built stuff. That's a big problem. You probably all know this from coding, right? Like this is a very human thing. You write some code, it's very complex, and you're like, oh, now I get it. I had to do it to get it. I had to get to the end so I understand how to start. That's something that always happens in reality. You get better at it as you get older, but it's pretty much impossible to avoid. The second problem you have is that, like, you know, sometimes customers or clients don't know what they want, right? There's an old joke about this. There's many old jokes about this, you know, just around, you say to a customer, they're like, oh, I want like a beautiful red website. So you build them a red website, and then you show them, and they're like, oh, that's disgusting. That red is so potent and powerful. Can you make something lighter? And you told me you wanted it red. I told you that red was a horrible color, and you said you like red. So when you're working with people, customers, consumers, clients, whoever, they often don't know what they want. Sometimes they'll change their mind. And in a lot of ways, that's why, again, you exist to try and help bridge that gap. If there was a totally perfect way for us to convert the human experience to define problems that we can engineer for, we would not need people to do it, right? We could build an app to do it, but we don't have that because people are complicated. Other problems are that developers might not understand the subject domain. This is super common. So, you know, if you're a software developer trying to help a university design a timetabling system, right? Or build a timetabler for them. If you don't really understand the details of how university classes work, and you know that labs are often attached to tutes, but they don't have to be, but they can be, and that there's not things in week 6. Like if you don't understand the university space, then it's going to be very hard for you to understand the problem properly. So when you engage in requirements engineering, you need to often ask yourself, you know, do I need to educate myself in this area? You know, what I don't know, what I don't know, stuff like that. Limited access to stakeholders is a problem. Whenever you're building software for people, you don't always have their time, right? Like if you're trying to build software for customers who often aren't going to give you their advice for free, you know, you can't just ask them every day what they think. You have to be very targeted with that because you do have limited access to them. And then the 6th item here, which I think is honestly the most important one and a great life lesson for everyone involved, which is the conundrum of when you're doing requirements analysis of trying to find a solution quicker than you're trying to understand the problem. And if nothing else, if you've tuned out till now, I just want to like establish this idea in you because it's probably one of the most critical. Is just like you could Google this. There's a Wikipedia page on it. There's a Metastack Exchange problem on it. There's a website now, which you can read about. But basically, I won't make you read this, but because you can go read it yourself. Is XY problem is a description of when you don't realize that you're asking about a solution instead of asking about the problem, right? And a good example, like an example of you doing this in practice might be if you're researching how to build, like if you're trying to do requirements engineering on the UNSW Dreams app and you're trying to elicit responses from people and you come up to them and you say, do you want to just have channels, just have direct messages, or do you want to have both? And then they say, I'd like both. So your requirement is, have both direct messages and channels. But the problem is you've immediately jumped to a solution there, which is direct messages and channels, where what your actual problem you're trying to solve is what is the best way for you to communicate? Like, how do you communicate with groups of people? Because it might not be either of those things. Sometimes we refer to this as overfitting, where you get so focused on a solution that you optimize the problem. For those that are math-minded, another way to think about it is like global and local maximums, where like if you imagine like if you don't think big enough, then what can end up happening is that you kind of start here with someone and you say, oh, well, let's figure out how to make this better. Let's figure out how to make channels and direct messages better. And then you make them as best as they can be, and you max out the best they can be. Whereas in actual fact, there's a much better solution over here that you've never explored because your original frame of thinking was so narrow, right? That's why we don't like to think too narrowly. In reality, the example I usually give 1531 students is a story I had once with a friend on campus where I think we were about to get lunch, and I had lunch, I don't know, like a burger or Guzman or something. And they said to me, hey, like, I need a fork. I like desperately need a fork. And I was like, okay. So we went around like asking for forks at places, and most of them wouldn't give them out for free. And we like, I thought I had one at my desk. So we went and looked for that, and we couldn't find one in the end. And what it turned out was that we were so busy trying to solve their problem with a fork. By the way, for context, I didn't actually know it was lunchtime yet. If I knew it was, I've told this story the wrong way now, but it's like, forget the lunch part for a sec. It's like they were looking for a fork, and we tried really hard to look for a fork, and we couldn't find one. And in the end, I still had these like chopsticks in my bag that I pulled out when I was rummaging, and they were like, "Oh, perfect, thanks." I was just like, I can finally eat lunch now. And they pulled out some, I don't know, rice and meat or something. And what was so interesting about that scenario is we'd spent all this time looking to try and find a fork or some other kind of like fork replacement, whereas that wasn't the problem, right? So if you're not, like Sarth says, like, why do we need the fork? And like, that's why is such an important question here, because your requirement in that case that you're working towards is not that you need a fork, right? Like, imagine I'm getting lunch with Miguel, and it's like, the requirement is not Miguel requires a fork to succeed in their day. It's like why? That if that's a requirement, that's an example of the XY problem, because the bigger problem at hand is, Miguel requires a utensil to eat food with. And that opens the horizon, right? Because you've got spoons and chopsticks and everything else. And like, what's the actual problem? And I think in 20T3, or maybe it was 21T1, I can't remember, 20T1, I explained this concept to students, and they kept going a bit too far. Like, at first it was like, why do you need the fork? And they were like, well, because I need to eat. And they're like, well, why do you need to eat? It's like, to sustain myself. And they're like, well, why do you need to sustain yourself? So there are limits to this. Like, you can't just idealistically keep asking why, because you reach a point where someone will just punch you in the face, right? And you don't want that. I don't want that. But the point of this whole story about forks is that when you go through all of these processes of requirements engineering and establishing requirements, which are essentially rules that dictate how you go about building a solution, it's always important to ask yourself that question: am I understanding the problem, or am I focusing too much on the solution? And this applies in everything. And to be honest with you, like, the reason I emphasize this so much is you would be shocked how often you can apply this to pretty much every single part of your life. From like random things you do throughout the day, to like social interactions, to like personal relationships with family or partner or something. It's like taking a step back and being like, are we actually, like, what is the problem at hand here? Or are we getting completely lost in this solution? Like a good example is, maybe you're late to pick up a friend, and your friend's like, I hate it when you're late. And you're like, is that the problem? Like, is that actually why you're upset? That, like, I'm late? And it's like, well, I don't like it when you're late because I'm standing at the door waiting. And it's like, well, so your problem's not that I'm late, your problem's that you don't know that I'm late, And then suddenly you've changed the conversation. And this just applies for everything. Random personal stuff all the way through to like enterprise engineering. So keep that in your mind. If nothing else, like, legitimately, if you only took one thing away from this course, it would just be that. I mean that sincerely. We've talked through enough examples. Normally, sometimes I talk through a monorail example, which is like, there's this old joke. By the way, this is a random ass monorail in If anyone's been here, I'd love to hear about it. But there's a small town in Germany called Wuppertal, and I don't know if it's a small town, but they have this random ass monorail. Wait, is that it? Where'd it go? The German. Okay, yeah, they have this random ass monorail that like looks super stupid. Just like runs along the river. How dumb does that look? Doesn't that just really inspire the natural landscape for you? But yeah, no, there was this old joke every April 1st, which is soon. Yeah, every April 1st, the UNSW SRC always used to put out a press release that was like, we're building a monorail on campus now, from like lower campus to upper campus, which I always thought was funny. Cool. I think it is cute. I think it looks a bit dramatic for what it is, which is carrying a tiny little car. Okay. So I'm hoping that after talking about this in a little more detail, you can get a sense of like what these requirements are. The last thing I want to say on the intro to requirements is that a lot of requirements end up being a set of instructions and rules and these things, capabilities, conditions, whatever. They're your Bible that you can reference against. If you write good requirements at every point when you're building software or building any kind of engineering solution, you should be able to look at what you're doing and look back at that and say, is the solution I'm doing satisfying the requirement? Where the requirement is an encapsulation of the problem that helps you push yourself in the right direction with the solution. I think just to emphasize as well, because I probably confused some people here, when I talk about this XY problem stuff, you can write requirements and follow the process perfectly without considering XY problem. You'll just get to a worse outcome. So XY problem just helps you write better requirements, but without it, without understanding it, you'll still write stuff fine. It's just you might get substandard outcomes. Probably the best advice as well that I got given, so during my short internship at Microsoft, my boss's boss, who was a test engineer, by the way, this test engineer was like partially blind. He could like barely see. And the thing that blew my mind was how much money he earned. Like he earned a lot of money. Like with stock options and stuff, it was less than $1 million higher than 500,000, right? Just as a software engineer. And I was like, could you imagine being like so smart that you could be like mostly blind and still be that valuable to someone? Do you know what I mean? Like, it's like if you lost your hands and someone still paid you that much money. You know, if I lost my eyes or my hands right now, I'd probably be worth like very, very little to people, like in the industry, right? So, yeah, like that. Anyway, that's been like a life goal of mine ever since. Is like be good enough be smart enough that you can be mostly blind and still be pivotal. But anyway, he told me something once. I didn't talk to him much, but I was asking him about test engineering, and he just said to me, he's like, defining your problem is the most important thing. Like setting out your requirements, setting out your like defining the problem you're trying to solve is critical, because if you don't understand your problem, you can't test it. And I think this is a really important thing to emphasize. Like, if you're writing tests for a solution that you don't have a clear set of requirements towards, you're just writing crap, right? Because the tests mean nothing. They're just you writing random tests. But if you can test against a set of requirements, then you can actually know if you're doing the right thing. So what he said to me was, I think he said, if you can't define a goal, you can't test a goal. And if you can't if you can't define a goal, you can't test for it. And if you can't test for it, you can't achieve the goal, right? So the point is, requirements matter, because without them, you can't actually ever accomplish anything, because you have nothing to measure yourself against. You have nothing to measure your work against, benchmark it against. Miguel, that's wild. Yeah, so think about that. Now that we've kind of gone through requirements, I just wanted to briefly mention this distinction, because it kind of comes up in some labs or tutes or maybe the exam, which is like functional versus non-functional requirements, right? So functional requirements, like these are two ways of broadly separating sets of requirements. Functional requirements specify what the system does, and non-functional requirements describe how it works or how it achieves that. Typically, functional requirements describe like a capability or a thing it can do, like hence what the system does. And non-functional requirements typically describe a constraint on the system, i.e. how it works. You know, so like an example with a phone is that, you know, if you say like a phone, and let's look at some examples that are better than what I pull out of my butt. This is an article I've linked because I think it's a great little bit of reading that you can go read up more on. It just kind of elaborates a bit more on like the difference between functional and non-functional requirements. But they have this nice little table down the bottom here, where they... Oh, is this the one with the examples? Yeah, so examples of functional and non-functional requirements. So here you go. It's like the sales system should be allowed to record customer sales. That tells you what the system does. Only managerial level employees have the right to view revenue data, right? That's like something the system does. So you're providing capabilities. This is the easiest way I think about it. Like functional requirements are telling you things you can do, and then non-functional putting constraints on that. You know, as in like nearly clawing it back, telling you what you kind of can't do in sometimes. Like for instance here, a website should be capable enough to handle 20 million users without affecting its performance. Like in that case, you're kind of saying, you know, this is a constraint. We can only deal with this many people. Every unsuccessful attempt by a user to access an item of data should be recorded, right? So again, it's like you're constraining it. It's like being a little less free. Now, one problem I generally have with teaching these things is that definitions online vary slightly, and then also I think it's a bit confusing, because if you think too much about it, if you overthink it, you could start arguing that some functional requirements seem like non-functional requirements. So my advice with this stuff is, here's an article to go read. Go and read it. It comes up in tutorials with your tutor, so you can talk about it then and there with them. But again, in simple terms, what the system does and what capabilities it provides is functional, and the constraints on the system or how it achieves that is typically non-functional. That's at the core of it. And yeah, here's an example here. Sorry, I forgot I had this example, which is like a functional requirement, if you're talking about some kind of email system, might be like, the system must send a notification to all users when there's a new post or someone comments on an existing post, right? So think about like EdStem or like the Ed forum. That's telling you something it can do. Whereas like a non-functional requirement here is like the system must send emails no later than 30 minutes after such an activity. I don't know what that from is there for. You know, and in that way it's bounding it. So yeah, there's a contrast there, but like keep exploring that. You can always ask questions. That pretty much brings us to the end of the requirements overview. So we're going to dig into use cases and user stories next, but let's take a 5-minute break now, bit of an early break, and then we'll plow through these next two topics. Should be easy. Let me send a quick, I got to do the survey. We'll do that really quick. But yeah, so cool. Thank you.